Welcome to all to KSN Structure Engineering classes. My name is K Shankaranarayana, which in short form I write it as KSN. I am in the teaching field in the structure engineering since past 39 years. All these days I was taking classes for academic subjects like engineering mechanics, strength of materials, structural analysis, and then RCC, steel, pre-stress concrete, finite element method, then matrix method, etc. Pre-stress concrete. Of course, strength of, now I am conducting the course for strength of materials, which is for civil and also for mechanical. For civil, it is called strength of materials. For mechanical, it is called mechanics of materials. Both are same. This course will be based on V2U syllabus, but useful for any university. Need not be for VTU. Strength of materials means a SOM. You people call it popularly as SOM. It is not for a particular university or a branch. It is strength of materials only. And further, here, this course will be purely examination oriented. See, I have a lot of commitments. I take professional classes here. Lot of commitments are there. But still, in between, I decided to help the students to overcome the difficulties for preparing for examination. As far as I know, examination for third semester will be after March 15th. So nearly, there will be 1 month time, sufficient. And this is somewhat like a crash course, but I have not written crash course there. I do not want to use the word crash course. It is a full-fledged course, but short, what is required, and to the point, and fully exam oriented, so that those who go through all the classes, study thoroughly, I can guarantee success nearly 100%. If you go through all the classes, study thoroughly, very happily you can pass. Not only just pass, you can get very good marks also. Now, I written here, important message to all. I am not writing there, I am telling in the class. See, I am in the same channel, KSN Structural Engineering classes. I am running a course that is for shearing force and bending moment diagram, popularly called SFD BMD. It is a part of strength of materials. But that will not be covered in this here. That I will tell later. Now, that course I already uploaded around 99 classes. 100th class is pending. I have to prepare. I am making the 100th class a special class with some special concepts. Now, the response is extremely good. So many people are getting benefited. I am getting so many messages because my number is known to everybody because of some demo classes. People, messages are pouring into me. This class is really useful. We are learning a lot, etc., etc. But majority are not seeing it online. I know maximum people, what they do is they download it and then see offline. Okay, it is your choice. I can't put any restrictions there. And what happens is, when I see how many people viewed there, number is lesser. It will take a little long time to get more number. And duration, if I upload a class for half an hour, 30 minutes, view duration, 3 minutes, 4 minutes. Does not mean that they see 2 minutes, 3 minutes and leave the class, not that way. They will download and see offline to save the data. But what happens to me is, I will not be knowing how is the response. Of course, I know the response because of other ways. So, this course, I will continue. Today I am starting. It is a conditional. If you are really getting benefited, or if you feel I am doing a service to this student community by conducting this course, you can go to the class, 1 or 2 classes you can make out. Then you should see it online. The reason is I want to know exactly how many people viewed it. That also counts. See, for a teacher, response is the most important. When response is extremely good, you get motivated and more spirit, means not that way, more enthusiasm will come to teach. Oh yes, all are getting benefited, so let me conduct more and more classes. And secondly, how much time you viewed. If you download from the YouTube and view it, it will show only 2 minutes, 3 minutes like that. If that thing happens to this course, I am not continuing. I decided, I am very firm. I got a lot of better works to do. Not that it's not a better work means it's not a bad work like that. I got my own commitments, lot of commitments. See, I have to make some time available in between that one to conduct this course. But I will conduct the course such a way that very simple. I always talk very simple language. I never go for stylish language like that. Day-to-day life, how we talk, that only I talk. The main important is you should understand each and everything. So, it is compulsory means I can't force it. You should not download first time. After once completely viewed, okay, then subsequently, if you want to see sometime it happens, a class, you may want to go through 3-4 times. Yes, download, no problem. But just to save data and use it for purpose other than education. I don't want to tell what purpose people are using data for. They want data for entertainment purpose. No. Entertainment is secondary for you. Education is first. So, I will insist on that one. Very good response. I should see the views. Tremendous views should come. And the duration, how much people watch each class, you will not be knowing. I will be knowing because of in the YouTube studio, I get each and every information. Right now, how many are viewing, I can see there. So, good views should come. On that basis, if you respond to that one, that is, I sometimes used to call selfishness. Selfishness is what? I want my data for other purposes. No, you should leave that one. You should think this person is conducting a course for our benefit. When he is so much busy in his day-to-day activities, he is somehow sparing the time to help us. Then in return, we should show him good response. So, watch online, first time, second time okay. And further, share to maximum people. As far as possible, share it. You should go beyond a particular limit there. And then I will watch. First class I am uploading now. I will upload one more class. Then I will see after first class, second class, I may upload within 1 or 2 days. Then I will watch. I will wait for 2-3 days. If response is good, I will continue and continuously upload. All, remember, very, very important parts I am covering, pure exam oriented. So that way I will continue. And one more thing. So further I will not tell. See, this point again and again I will not tell. Once I told, sufficient. That's why I told important message to all in the class. Now it is left to you. I should know whether the present generation of students, they deserve my class which is purely knowledge oriented. I should know it. Then only I will continue. Otherwise, no, I will simply stop. Whatever request, sometime comment will come. Sir, we want to continue. I will tell no. You don't, not you means you actually. Present generation does not deserve it. Where undeserving people, I don't want help. This is a pure, see, this is a free course in YouTube. I am starting a course for first semester for elemental civil engineering. That is my own course. Because for that course, there will be registration charges will be there. You can see a demo class uploaded in my channel. See, in this one, you can see a demo class uploaded. You can tell that for your juniors. So that is professional class. But this class is entirely for as a service-oriented class. So if you want to get maximum benefit, show response. That's all. Further, I will not tell. Now, see now, till the end of class, I will not tell anything. If I decide to stop, I will not announce it here that I am stopping. I will simply stop. That's all. I don't want to ask you once again, see, you are not seeing properly, you are actually downloading it and what, not sharing, etc. More views are not coming. I will not tell. I will just decide. Present generation does not deserve my service or my knowledge to be used. Second one, at present it is recorded. So time also equally important. So usually I write. Usually I never do that way. In my regular class, I write in front of students. Communication will be there. When I want to write something, I will ask. Problems also, I will write there. That is more powerful because environment. It is a recorded class. So if I write in front of you here, it will take a lot of time. Time also counts. So I will explain here everything. Some special questions, important, I may write in front of you only. Now, instead I decided, I can come live in YouTube. But for coming live in YouTube, there are some requirements. See, I started my channel nearly 7-8 months earlier, that's all. Requirements are there for coming live in YouTube. First is subscription number. What requirement is there? I nearly reached 90% of that one. See, YouTube permits live broadcasting if minimum or when the subscription number touches 1000. Mine at present is around 900. So even in all that SFDMD class, I never requested anyone to subscribe. I never asked them to what? Like, etc. I always tell, liking comes from here. It is not to be forced. You can't tell someone, hey, come, wish me, good morning. No. He will tell good morning if he likes, or in Kannada or in a local language, sir, namaskara. They will tell from heart. You don't tell him, wish me like that. So I never request anyone for anything here. But here also, I am not requesting first of all. If you want to my course to be continued, I have put my conditions. That you have to satisfy. So, those who have not subscribed, you subscribe and tell others also to subscribe. The moment it becomes, I am become eligible means not that eligibility, the required number of subscription touches there, I will make arrangement for a live class. It will be very beneficial for you. Live class means some time I will fix. Live class means what will happen is after the class recording, it will be available anytime. But you can come live and communicate, and with the chat section, you can get so many doubts clear. You can ask which is not clear. First of all, I will tell you, offline class or online class, in my entire teaching so far, not a single one told not clear. That word will never come. I am so sure, whether it is online or offline, doubt never comes in my class. I take care of that one. Sometimes people ask, doubts will be clarified. I will tell doubts will not be clarified, because doubt will be clarified if doubt comes. When doubt only will not come, what to clarify? So I believe a correct teaching is one where there should be no doubt. Whatever you want to tell crystal clear. Tell repeatedly. But offline classes I tell repeatedly. But here, repeatedly not required, because you can repeatedly go through. Once you some important concepts solve, once you understand, go through again and again till you master it. And second one, everything you have to make a note. What or see, sometime I can see here, I wrote somewhere here class, I don't know where I wrote. Somewhere I wrote a class here. Sometime I write here, class. See, here also I write class. See, here also I write class. Class means what? In future, if I write class means something dictated in the class. You should stop, listen slowly and make a note. It is for your benefit only. Okay, now that's all. Now, based on the response I told, I will decide to continue or not. Okay, leave it now. Now, all those things, leave it now. Now come to subject. And one more thing here. I am not covering the entire syllabus. It is not a full course. It is not possible also, but I will select the chapter so that you can easily answer minimum 4 questions. Some will tell, sir, over sufficient. See, so many have difficulty for passing. 4 questions means 80%. Then little you can study yourself. If I am not making the course, what you will do? Do that one only. So I will nearly cover 80%. What all I will cover, I decided there, but that slip is missing here. It's not here. So I don't want to imagine and write. I will write, give the next task. Or little later I will tell what all I am going to, second round. When I remove this one and go to new part here, I will write what all I am going to cover. I will tell you at that time, see, these are I am going to cover. No notes will be given by me for this one, because if time is there, I would have prepared notes and given in PDF format. But right now time is not there. What I tell or what I write here, that itself is more than notes. And secondly, one more point. Theory portion, too much I am not covering. See, derivation, if required, I am covering. But theory portion, like for example, first chapter is stresses and strains I am covering. Lot of things are there in stresses and strains. Ductile material, brittle material, yield stress, proportionality, and then ultimate stress, breaking stress, etc., etc. Sometimes they ask problem. That I will solve here. But those theory all you should study. Some property, ductility, then what malleability, Then so many other properties are there for toughness. Those properties you study from books. Books name I will not give, search anywhere or some notes. Study theory portion, helpful for you. This is maximum I am doing problems here. And derivation is also like a problem only. It is not a story like theory. So I will concentrate maximum on basic mathematical part or what all problems required for you that I will solve with important derivations. See, I told my talking speed is slightly high outside, but when I come to subject, it is not. See, this is the introduction part. I am not good in speeches all. You can make out later. This way I don't take classes. When I come to subject, my way of teaching is different. You will wonder now within no time. Same person was talking that way, now change the tone. See, when I go to subject, you see the difference now. How I insist on the points. Okay. Now, I will start one by one. Write a note wherever requirement is there. Or what all I tell, write it. What all I tell, write it. Sometimes I give some money matter example. Sometimes some concept will not be clear. Doubt comes. You write that also. If somebody asks you, what is money matter coming? You ask him to keep quiet. Sir told us this one, it is useful for me, I wrote. Who are you to question what I write? It is your knowledge which is important, not others' comment. And people will be there to comment. He is starting stress and strains, directly started stress and strain without telling material property all. I told you, this is not not a crash course, but like a crash course only. What all important problem solving techniques required, that I am covering. 90% people want that only. So my purpose is to help majority of the students of civil or mechanical or also some industrial, other batches are there. Anyway, subject is known to you. Those who require, they will go through it. Okay, now start the serious part. I will not discuss anything about what I told here in future. It is for you to see that course will continue with very good response so that I feel, yes, my classes are really useful for students. I feel satisfied and what more enthusiasm will come and also what you can tell is more inspiration will come. Okay, that's all. Start now. See, first you remember stresses and strains I will tell little later, chapter wise I will write here. Before starting, see, one term is called equilibrium, one is called section forces. See, you can see a change of tone now. Equilibrium and section forces are different. In equilibrium, we consider member, any member, it can be a beam or it can be a column, it can be a slab. Though too much I will not tell because it is not a professional class. If it is a professional class, equilibrium section force, I talk more than 3 to 4 hours. So many finer points are there regarding load transfer, supported member, supporting member, action, reaction, what is the important, how resistance comes, that all I talk. Here limitation is there. So within the limited time, I should tell equilibrium and section forces. See, this equilibrium is in engineering mechanics. You can make a small note here. This comes in engineering mechanics or elements of civil engineering in the first year. Section forces comes in strength of materials. There is a difference between engineering mechanics and strength of materials. Engineering mechanics, we deal with the force system. We would never bother about the effect of the forces on the member or failure of member, deformation, nothing considered. In strength of materials, see, word only is there, strength. When strength comes, see, question comes, whether that load can be supported by member or not, etc. will come. So here we never bother about effect of the forces. Effect means internal effect, you can tell that way. Internal effect like section force and deformation. Here we consider internal effect or how member is resisting the section forces or how the loads are supported, that will come. Now see, our discussion is only for coplanar force system, no three-dimensional. For coplanar force system, equilibrium means we consider sigma fx0, sigma fy0, sigma m0. Means algebraic sum of the forces in x direction equal to 0, algebraic sum of forces in y direction equal to 0, and algebraic sum of moment about any point equal to 0. Because when the body is in equilibrium, it should neither move this way, nor move this way, nor rotate. Now, what I prefer is, for strength of materials onwards, I don't use sigma fx, sigma fy, I use simple language. In full structure engineering, I use sigma v0, sigma h0, sigma m0, sigma, okay, see, actually interchange here, okay, interchange, no problem. Corresponding sigma h first. This is all okay, no problem. See, in my class, sometimes some writing mistake will be there, this side, that side. Rarely spelling mistake can be there. Grammar mistake, usually I don't commit, but technical mistake, there is no place in my class. I never regretted telling anything so far, or I never used the word sorry, that is wrong, neither up to today, nor in future, that mistake will not come. So, sigma fx 0, see, algebraic sum of forces in x direction 0 means horizontal. Sigma fy 0, algebraic sum in vertical direction, we call sigma v, sigma m. We will be using this one, or simple language, algebraic sum of forces in x direction 0 or horizontal 0, in vertical 0 and m0. And very important, when you apply this one, sigma s, sigma, sigma m, we consider, once again it will come, we consider action and reaction. That is very important. We consider action and reaction, or you should make a note here. A member will be in equilibrium under the combined effect of action and reaction. See, simple. I'll apply a force here. See, member is moving. It is not in equilibrium. I'll finally touch the board. See, now it is not moving. Why? I'm applying a force this way, action. From that board, a reacting force will come this way. See, reaction. You push your friend, or don't push the friend, someone you push, he will fall down. No equilibrium. Suppose he is strong. When you push him, he will push you back. So that fighting will start. Then see, equilibrium can be reached. Or if I take a chair, there's a chair here. If I push the chair, see, the chair moved. No equilibrium. But if I try to push the wall here, no, wall will not move, because from there reaction will come. So when you consider equilibrium, we consider action and reaction. Remember, together we consider. Furthermore, I will tell later. Now, corresponding here, section forces. These all will be told today. Just briefly note down. There are 4 section forces: axial force, shear force, bending moment, and torsional moment. I will tell once again now. See, sigma h0, algebraic sum of forces in x direction, horizontal 0. See my hands. Algebraic sum of forces in vertical direction equal to 0. Algebraic sum of moment, rotational effect equal to 0. You can observe one thing. See, I told right side, upward, and rotation, maybe clockwise or anti-clockwise. See, sigma h means can be right side or left side. Sigma v can be upward or downward. Rotation, clockwise moment, can be either clockwise or anti-clockwise. You might have observed one thing now. I always ask the students, tell me something. Sir, right side. Tell something else, observe. No, sir. Okay, leave it. Later you tell. Now, section forces are different. Section forces are axial force, shearing force, bending moment, and torsional moment. Like, see now. I'll take a member here. Member is getting compressed. See now, compressed. Axially passing or tension. See, compression or tension. This is called axial force. You can write here, it can be either compressive or tensile. Briefly I am telling, you can write compressive or tensile. Shear force. See now, some paper is there. Shear force. See, or representing, see, shear force. See, axial force, compression, tension, shear force. Then bending moment. a member you are going to bend. I can show a better version for that one. If it is there here, some model should be there. Okay, so I got some model. See here, bending. Here we got two terms, bending especially. It can be sagging or hogging. Later I can write. Shear force I will explain later. See. Sagging, hogging. Lastly, twisting moment. Best example. Take a cloth, put in water, wash it and remove the water. How people remove the water? Okay, I will use a cloth here. There is no cloth here. Put in water. See now. This way. This all everybody knows. This is torsion. See. Now I will tell here only, this paper only. Axial force can be compression or tension. Shear I should be careful. See. Okay. Okay, no problem. Shearing force, bending moment, and twisting moment. Now I ask the students, now can you observe something? They will tell, sir, sigma h right side, sir. Right side comes in axial force also. Sigma v upward comes in shear force. M means bending shear comes. No. Something else have you observed? Those who already came to my class earlier, they will tell. I will tell them, don't tell. Remember, observe one thing. When you discuss equilibrium, it is always direction based. See, third point. This will come later. It is always direction based. Like, I will not repeat. You go through the class repeatedly. That's all. If it is an offline class, I have told 4 or 5 times. But here, no. Those who want to learn, they will again and again go to, oh, let me learn. See my hand now. Sigma h, right side or left side. Sigma v, upward or downward. Sigma m, clockwise or anti-clockwise. Direction based. This is not direction based. It is nature based. You don't tell compression this way. See? Compression, tension. See, one side is going up, other is coming down. So you should not tell up and down. When one side, see, bending. See what happens to bending? If I bend this way, that is clockwise if I apply here. Here I am applying anti-clockwise, see. So direction is not to be used. So many people, they use direction for bending moment. It is wrong. In that course, SFD, BMD, I have taken around 35 pre-requirement classes. Not for you. Not worth for you because you are studying strength of materials. Or if you want, you can go through. There I told each and every point. Therefore, this is nature-based. Remember, direction-based, nature-based. Or I will give one more crude method for you. Don't tell anybody. Serious matter. Crude. I lastly write here. Okay. I lastly write crude somewhere here. Crude. Crude method. Okay, leave it. Useful for you. Crude method. Someone tell crude is telling. Not crude. You can write crude means easy method. Equilibrium you can explain with only one hand. See here. Right side, left side, sigma h. Upward, downward, sigma v. Clockwise, anti-clockwise, sigma m. Section forces, you require both the hands. One hand you can't compress. One hand you can't shear. One hand you can't bend. One hand you can't twist. So you require 2 hands. See now. Compression, tension. Shear I will show here only. Shear. See bending and twisting. So you need 2 hands, crude method. Okay, next, very important, second point. Here we consider load transfer. Load transfer means, suppose you have a beam. From slab, load will come to the beam. Then it will be transferred to column. Here, slab is called supported member, whereas column is called supporting member. So, here you can tell load transfer from supported member to supporting member. supported member, you receive the load or load transfer. See here, you get two terms. You should write here. Here you get two terms. One is called supported member, other is called supporting member. Load is received from supported member. Supported member. Load is transferred to supporting member. If you tell slab, beam and column, for the beam, if you consider, slab is supported member. From the slab, load will come to the beam. From the beam, load will go to column. Column is supporting member. So you should write not this way. Load transferred from supported member is transferred to supporting member. Load transfer. Load transfer. Two I will not write. I will write this way. Load transfer. Supported member and supporting member concept is required. Right that way. You need a concept of supported member and supporting member. See here, load is transferred, but section forces not that way. This axial force, shear force, bending moment or twisting moment or torsional moment, they are to be resisted, not transferred. See, if a beam is subject to heavy bending, load on the beam can be transferred to column. But beam cannot tell the column, I am having difficulty, too much bending is there. Can you please take some bending? Column will tell no. You transfer your load to me, I will transfer to foundation later, from column to foundation. But bending problem, your headache, you take care of it. So remember, in equilibrium, our main concern is load transfer. Some people tell load is resisted. No, loads are not resisted. It's a wrong concept. Loads are transferred, section forces are resisted. So here, section force effect on cross section. Here you take load transfer, supported member, etc. Here you take effect for cross section. You consider resisted by the cross section. All these section forces are resisted by the cross section. And further, see, very simple. Sign convention is required for both the places. And again remember, here, sign convention based on direction. How? Right side, left side, upward, downward, clockwise, anti-clockwise. Here, sign convention based on nature, compression, tension, whether this way shear or this way shear, sagging BM or hogging BM, like that. And one more important, when you consider equilibrium, sign convention has no effect on the answer. I will discuss later. Today not possible now. I will explain it. I will show you why. Sign convention has no effect on the answer. Means irrespective of whatever sign convention you take, answer will come same. Suppose you take upward positive or downward positive, or when you apply sigma as 0, you can take right side positive or left side positive or moment, clockwise positive or anti-clockwise positive. That sign you consider has no effect on the answer. No doubt, sign is required. It has no effect on the answer. But section forces, sign convention based on nature, sign convention has effect on the answer. It has effect on the answer. I will tell this one little later. Now it is too early, so time being, you believe me. For that matter, everything I tell here, you have to believe. If I ask my students, you will believe? They will tell, sir, don't ask the question. There is no question of not believing you. Okay, now next, most powerful, when you consider equilibrium, you consider the entire member. So, for example, see, I'll write here. Suppose there is a beam, you write that way. Some reactions are there, some loading is there, any loading, etc., etc. Okay. When you apply, consider equilibrium, you consider the entire member. You write here very clearly. I wrote here, see, entire member. Or you stand here and consider the entire member. But when you find section forces, you have to consider only one side. See, only one side means, suppose for some reason I want axial force or shear force or bending moment or twisting moment somewhere. Suppose I want here. See, I will write here now. If this point is A, this point is B, there is a vertical reaction VA, horizontal HA. Just imagine a reacting moment MA, Imagine here only vertical reaction VB, just like that. Now, if you are applying equilibrium, full VA, HA, MA, VB, this load, and this load means entire, repeatedly go through, entire member to be considered. Some E got rubbed out there. Entire member to be considered. But when you want section force, only one side. Means suppose I want some section force here, like axial force or shear force or bending utility moment. If you want here, you either look this side or look this side. Never look both sides. Equilibrium, entire member, section force, only one side. See, or easy to remember or crude method. I will tell easy or crude. Easy or crude. Okay. Crude only will do. Sometimes crude method helps. Easy or crude method. See, when you consider equilibrium, you look this side plus look that side also. Look both sides. See, class. Or you write here, when I consider equilibrium, I will look this side and also look this side. Means I am looking both the side, complete member I am considering. But when I want section force, somewhere see, for example here, then either I look only this side, never look that side. No, this side, no. See? No, no. Or you can look that side. If you look that side, then this side is no, no, no. See, for example, imagine a beam runs here. Some reactions are there. If you apply equilibrium, see, complete beam. But suppose I want section force here, like axial force or shear force or bending moment or twisting moment, then either like this. Someone calls there, look this side. No, not looking. Or look this side. Never do. No. I think repeatedly, if you go through all this one, you will understand. So make all these notes. Now I will start. I will write what are all the chapters I am covering, and then I will start the first chapter. As I told, too much of theory I will not discuss here. Theory you have studied from any books or notes, whatever you want. Majority are having, I think, no, those things all. Here it will be correctly systematic approach to do the problems. 80% marks will come from problems only for you, or derivation. Derivation I will do it, because why? It is like a problem only. Okay. I will remove all this one. I will make a note what all I am covering in this course. In case exam postponed also, I will not go for extra. Full-fledged course I can't make here. There is a limitation. Therefore, you study thoroughly whatever told here. Every day go through. Frequency of the classes depends upon my time availability, but I will see that by chance if March 15th is exam, I will finish by around 10th. Suppose exam is on March end, I can go up to March 20th like that. I will be knowing earliest possible. Accordingly, I will plan. But nearly 4 questions you can solve means it is more than sufficient. Okay, I will write all this one and start fresh now. Okay. Now, I wrote the pattern of the class or how the class will continue. See, third semester civil, it is strength of materials, SOM short form people use, 18 CV 32 as per VTU. I told here, any other university outside state also will do, subject is same, but little this side, that side. Whereas for third semester mechanical, mechanics of materials, MOM, I don't know whether you call it or not, 18 ME 32. Okay. Now, I am forming the syllabus here or how I conduct the course based on civil, because I am from civil branch and it is equally useful for mechanical and other industrial. I think other branches, maybe some other branches are there. Mechanical syllabus I don't have here. I have not searched it, but roughly I know it. That also is almost same. Little this side, that side. Little this side, unit wise, that is unit or module type. Little that side. You see your syllabus and adjust it. Or suppose what way I conduct the class here, if slight change is there for you, at least what I am covering is useful for you, you can use it. Okay, now see, 5 modules are there. Module 1, simple stress and strains. Right mark means I am covering everything, full. So therefore, see, you get 2 questions here. You get the choice also. If you study only my class, even you get the choice. That is your advantage. Okay, then module 2, compound stresses. And there is 2 parts there. One is compound stresses, other one is thin and thick cylinders as per civil syllabus. Mechanical, I don't know. Maybe mechanical, it is separate unit, module it may be there. Now, compound stress I will cover. If possible, I will cover thin and thick cylinder because it is very useful for mechanical, I know it. But based on time, I put question mark here. Subject to availability of time, because I cannot finish this and finally leave the other module here. I will first finish compound stresses. So, for civil, 1 question will come. Mechanical also 1 question will come. Now, I don't know where is this in mechanical. So then, after everything is over, in case I get time, I will finish this one. Very simple it is. Then, module 3, shearing force and bending moment in beams. No, because in channel YouTube, KSN structural engineering classes, SFD, BMD, I already uploaded, I told 99 classes. But all those classes are not required for you. If you study all those classes, you cannot afford. So lastly, I will tell you which class number, which problems are important. I will give a list here. Only study those questions. Okay, further I can't tell anything because I am running a full-fledged course. See, sometime a subject in the college allotted time is around how much? 30, 35 or 40 hours. SFT, BMD, 100 classes over, 1 chapter. Another 100 are coming up. So 200 classes. That is a full-fledged, complete coverage of SFD, BMD. Very useful for practicing engineers or those who want knowledge. But for you, later I will tell you which class questions are important. You study it. Okay. Then, so this is, I cannot tell not covered, in this course not covered, but in my channel it is covered. Okay. Then, module 4 is bending and shear stresses. No, this is a lengthy one for me. I can't afford. But along with this one, in the same module, other is torsion in circular shaft. Very, very easy. I will make everything, I will make easier. Any complication, people who come to me, to come to my class, they will tell, sir, nothing, no worry, nothing, nothing means there is nothing which is not understood by us. So, this I will cover. So, module 4 also I am covering for you. Then, module 5, deflection of beams. Again, no. Little lengthy. I cannot afford it here in the time. So, columns and struts I am covering. So, all the 4 modules, 1, 2, 4, 5, I am covering. This is actually, I can tell, covered in my channel. So, if you consider that channel, YouTube channel, and go for that SFD, BMD course, 5 questions are covered. But okay, I will cover here 4, that is lengthy one. I will tell you which are required. Mechanical, little this side, that side, you adjust it. I cannot satisfy both the requirement. Primarily, civil is my branch, so I am a structural engineer, so I concentrate here only. Now, one more thing. Even see, suppose you study shear force bending moment little. Bending shear stress, I am not covering here. But if you understand everything I am telling, you can do self-study also. Or you already may be knowing little. Doubts are there. Those doubts will completely vanish. If you completely go through all my classes, those doubts will vanish. So suddenly you will feel, now this chapter, earlier I thought difficult, suddenly becoming easier. See here, deflection. Some will tell, sir, earlier difficulty was there, but now after going to all this one, suddenly I am finding I can solve the problem. You study. I told this is limited time course to see that people are benefited maximum possible, keeping in mind people who got difficulty or weaker students. Those who are very strong, they get extra knowledge from me. Okay, now this is how the class will run. Okay, now I will go through Next part, that is I am starting subject. I will put heading here. See, simple stress and strain. Next time onwards, I put class number 1 here I wrote. I add one more now. What is chapter I am writing? And then see go further. So class 1 we are going for. I will put heading here only now. Next class onwards I will put the heading. Okay, okay, okay. We will continue. See, chapter 1, simple stress and strains. I written there also. Chapter 1, simple stress and strain. Note, same I want to maintain for first class. Important message in beginning of class. I told I am not talking about it now, but you should go through it. It is important. Your continuation of the course depends on that one, as I told. Want to gain something, should be ready to sacrifice something. It can't be a one-way traffic. One-way traffic, road is okay. Here it is not one way. Or here, what all I tell will count. Now see, chapter 1, simple stresses. Some statement, see, in the class number 2, I will give you some fantastic examples. Stresses and strains, confusion is there. I will talk about some money example I will give you. It will become crystal clear. What all doubt comes. See, when you apply a load on a member, stress will come. Load severe or stress severe. Some will tell, sir, load severe. No, load is not considered for severity. Stress is considered. Member will elongate or shorten. Deformation. Strain will come there. I will ask again, which is important? Sir, how much it elongates, or in a beam, how much it bends important? No. It depends on strain. You can have more deformation, but still member can be safe. Lesser deformation, member can be unsafe. Or high load, a member can be safe. Lesser load, another member can be unsafe. So our deciding factor is not load and deformation. Deciding is stress and strain. I will tell in the next class, not this one, and one more thing, in the next class, a big table will come here. All complete chapter wise, how to remember, what format you have to remember, everything, terms, meaning, unit, and some important note, maybe full board it will come. You should go through, you should take a screenshot of that one and study repeatedly. Okay, that is next class, not now. Today, I will start the course now. See, some statement you have to write. I told us already, usually when you start this chapter, people tell, consider a member of length something, apply a load, member will, if you remove the load, it will come back to original position, increase the load, some stress and strain will be there, and then elastic limit, Hooke's law, when you remove the load, it will come back to original position, then it is called within elastic limit, or stress is proportional strain up to proportionality limit. There is term called yield stress, then upper yield point, lower yield point for some ductile material like steel, then ultimate stress, then breaking stress, etc. will come, crushing stress. That all there is no time here. I told it's a comprehensive course to understand or how to face examination. But I will give maximum information for you. That all you study books all. Any book will do, good books. I don't want to suggest any particular book. If at all you want to suggest me, I will suggest Ramamurtam. I have a lot of respect for Ramamurtam. When I was a student long back, I used to study Ramamurtam. Nowadays I don't require books all. I come to the class with only pen. And for recorded class, I come with the calculator. But for live class, I don't bring calculator. I never come with a prepared problem. Write the problem here, solve. So, but here I have do my calculation till it becomes live. So I told when I reach that, when I am able to go for live classes, I will go for live. But again, there, it will be only subscriber based. All cannot to come live. I will put a condition there. The link will go to only subscribers. They will get the link and they can attend. So as I told, those who subscribe, they will know. Others, they can go to record only then. Okay, now, see. Again, comments will come sometimes. No theory told, simply started the expression. I will tell them, want to tell theory? Shall I tell it? Can you digest it if I talk? I will tell you cannot digest. Anybody who comments, I will see that he will go back and telling, I don't want to talk anything with him. I can go to very high level, but I am not going. I know student capacity. I always believe talk in simple way. Tell the things in simple. Some unnecessary complications, avoid it. And theory portion, don't tell too much in the class here, especially for such courses. Concentrate on their difficulties or what they want. Okay, see, consider a member of length L. Member of length L. See, I written both sides here. Somewhere in between, I written here. These statements are for both. What I wrote here is for this sketch. What I wrote here is for this sketch. What I put double arrow mark this way is for both. But next class, you are getting a big table where this will come once again. Okay, see, member can be either tension or compression. So, this is a case of member in tension, this is a case of member in compression. Now, you cut the cross section, very, very powerful. See, this way, you have to cut it. How is the force going? You should take cross section. If you see this pen here, the section is circular. Or if I take my calculator, you can tell cross section is rectangular. Okay, leave it now. It all will come later one by one. One example I will give you where I will apply 3D force. For each force I will ask you, and I will not ask you, live class I will ask. Here I will explain what is length and what is area. I will make it clear that you require later for three-dimensional force system when you go to lateral strain, ending part of this chapter. Here, common for both, P stands for axial force. It can be either tensile or compressive. Now, come here. Here, axial force is P, see, tensile. Here, axial force is P, compressive. Over. Delta L is the original length or initial length for both of them. Initial length or original length. I will use the word original length, L. Now, A is cross-sectional area. Yes, common for both. It is how the force is there perpendicular to it. I will explain more about stress next time, why it is perpendicular. Next time I will explain. Okay, now, delta stands for increase in length. Delta stands for change in length. Change in length. Delta L I am not using. Later when you consider linear lateral, then I will put lin and lat. In the beginning, simply delta. Some people, instead of delta, they use this delta. No problem. That is symbol problem. A symbol you take whatever you want. But if you attend my class, consider my symbols. Delta is change in length. Now, if I come this side, member is in tension, member will elongate. The delta is increase in length. Here, delta will be decrease in length. Now, increase in length is sometimes called elongation or extension. Decrease in length is called contraction or shortening. Somebody on the road also knows it. Okay, then, sigma, see, red color item. See, one red is for area, other red is for sigma and epsilon. Sigma is intensity of stress or simply stress. Further discussion later I will tell you. Time being, leave it now. Because there is a limit here. Today I can't explain. I want some more explanation. Next class I will give you. Today, believe me, sigma is how the stress will come, how the member will resist it. I can tell now, no, right now, first I want to give brief introduction and bring you to a level. Technical points, some of them will come in the next class. I will tell you clearly how the stress will come. So today, just I wrote the symbol here and expression here, consider it. Because actually, you are going to college, you are studying. By this time, you will be knowing it. Even if I don't tell also, no problem, but I am telling. Now see, here, the sigma is tensile, here sigma is compressive. Then epsilon, see, be careful, epsilon, there is one term called E here. We should be careful. I will explain later. Forgot right here. Okay, I will write one more here. See, I sit and write. E stands for Young's modulus of elasticity, common for both. Just 1 minute. Let me check the board first. Sometimes it happens. You write it very below. It is out of camera means problem. Okay, slightly I have to lift. Okay, 1 minute now. I have to slightly lift the camera. Okay, now okay I think. Okay, 1 minute. Because I do not want anything to go out of the board. Okay, no problem. Next time again it comes. So today I am telling now, E stands for Young's modulus of elasticity. This I will discuss in the class number 2, not today. Today no technical discussion, simple application, just to make you comfortable. You should have a feeling, yes, this is where we are learning a lot. Now, be careful. One term is called, I write a black color, E. E means, see, capital E. Other is epsilon. See, they looks like same. Sometimes people write E this way, epsilon this way. Both look same. So be careful. See, this way if you write, it is E, Young's modulus of elasticity. Whereas this is called epsilon. This is for strain. This all I will explain next time. So epsilon means strain. E is Young's modulus. Okay, leave it now, time being, because next class it will come. Now, then here strain is tensile, here strain is compressive. Remember, I will explain in the next class why stress equal to force by area. Very important concept. Some money matter also will come there to understand. So today, actually all of you are knowing, stress is resisting force per unit area. So force by area is stress. One important concept over now. Stress equal to force by area. Now, what I will do now is, I will not continue further. But I want to do an example. Sometimes people will tell, no, not much theory told, problem suddenly. No, to give you confidence. So therefore, little more I will write here now. Little more I will write here now. See further. Once you get sigma equal to P by A, remember, then you will be knowing later delta equal to, I will write here, PL by AE. PL by AE. This all I will prove in the next time. Today I want an example. At least one problem I want to solve today. See what happens is, people get confidence. You should think, if not told today, next class I will tell. Delta equal to PL by E. And now, in the same delta, I told P by A is one more thing. And strain epsilon, see strain epsilon equal to delta divided by L. This will be completely covered tomorrow. I will put next class. This will come in the next class. Today, believe me, epsilon equal to delta by L. Ratio of change in length to original length. Now, some important aspect now. See, correctly concentrate. Here, I told delta equal to PL by AE. Already told for you. I will prove it tomorrow. Not tomorrow, next class. Now, you already know P by A is sigma. So, if you replace P by A by sigma, then your delta will become, see, your delta will become P by A sigma. Sigma L by E. Area will not come. Sigma L by E. Okay. And also, one more aspect. Here, delta equal to PL by AE. See, P by A, you replace by what? Sigma. Now, little later, you will be knowing that, I write here, next class, you will know that stress divided by strain epsilon equal to Young's modulus of elasticity. It will come in the next class. Stress by strain equal to Young's modulus. Therefore, if I substitute here, what will happen? Or your delta will also become, see, stress, see here, if I write stress by strain Young's modulus, or if I write this way, if I want epsilon here, I can write stress divided by Young's modulus. This will come in the next class. No problem. I take the class the way I want it, not based on comments I take the class. I know what way to take the class. People who comment suddenly came there, I will tell them, in that case, come and have discussion with me. Now, so see what will happen now? Your sigma by E is epsilon. So your delta is also equal to epsilon into, see, into L. I am telling why I am telling it now. So for delta, we have three expressions. Based on force, PL by AE. Based on stress, sigma L by E. Based on strain, strain into L. There's a reason for this one. I will tell you. In the simple case, we use this one. When you go to later composite member or temperature stresses, then you use this one. Further later, when you go to volumetric strain or when lateral strain etc. considered, we consider this one. There's a reason. These all I will make fully clear in the next class. Nothing to worry. Today, what all I wrote here, see correctly, sufficient. Okay, now, apart from this one more will come little later. I will tell now only. It is called strain energy stored. Because what I am doing now is to give you confidence, I am going to solve a problem. See, I know it. Ultimately, problem counts. When you understand the problem, people will tell yes, full clear. Like in a function, whatever you do, ultimately food counts. See, when you go to a function, whatever you do there or what arrangement, ultimately what counts is the food. That is where they have to give maximum effort. Nice meals means you tell very good meals. See, that's all. Other things you forget. Or you will tell everything is okay, worst food. See, gone. So, strain energy stored. This energy stored. Symbol is U. Remember now, today you just believe me, one formula is P square L by 2AE. This is formula based on P. Whereas the original formula is U equal to half into P into delta. Then see, formula is half P delta. I will explain next class. When you substitute delta equal to PL by AE, it comes. This is strain energy stored full. Whereas one more is there, I will write here now. And also note, strain energy stored per unit volume. This also required. Unit volume equal to sigma square by E, 2E. Forgot, see. Sigma square by 2E. Now I am going to take up a numerical. I told you purpose. So many theory part is pending. Sometimes it happens, tell too many theory, it becomes a little boring also. People will tell, when is the problem coming up? Or too much of talking, suppose you go to some place, if they keep on talking, you will think, when they are inviting for food. So therefore, the food is the most important. The food when you go somewhere is like problem in examination. So, and again, such courses, I can change the order. There is no restriction, but I will not do that way for a systematic course. No. If it is a full-fledged course, I conduct by not in the YouTube, by my institute name, then not that way. Then I always go systematic way. Okay, but here, this is systematic only, but little adjustment so that it will suit you. Okay, now, with this data, now I am going to solve a problem so that you get confidence. Then you decide. Then you go back and see this note and decide what I told. Is it correct or not? You decide. If yes means what I told, follow it. Okay, I will remove everything now. As usual, to save the time, I will write the question here. But solution I will do in front of you only to get confidence. And one small homework I will give you. You work out that one. Okay, I will make ready. Now we will continue. I told earlier I saw in front of you, but I saw the time. Duration is already more. So no problem. Next time onwards I will explain. So I wrote the question here. See, question. A member of length 2.8 meter has a width of 25 millimeter and thickness 12 millimeter. So I will tell you how is the member now. See, I will take this calculator. Member length is 2.8 meter, little long this way. Long, 2.8 meter. If I take the cross section here, width is how much? 25 millimeter, thickness is 12 millimeter. So some material, we don't know what is the material. Then it is subjected to axial tension of 48 kilonewton. See, I have shown here 48 K in this way, this section force or axial force, you should not tell right side, left side, tension or compression. Both hands are required, I told earlier. Then, modulus of elasticity of the material is 200 Kn per millimeter square. Usually nowadays, they give in GPa and MPa. That conversion I should give you next time. Actually, 200 Kn per mm square is nothing but 200 GPa only. But next class in the table, I will cover everything, that conversion, gigapascal, megapascal. And what they want is find, see, simple question. 1, intensity of stress. 1, 2, change in length. 3, strain in the member, axial strain. Furthermore, next time. Lastly, 4th one, strain energy stored. Solve systematically. That's how you should understand. See, first, solution. I sketch the member here, length 2.8 meter. Axial force 48 kilonewton. If I cut the member here, see, cross section, you can see, see this sketch is cross section. A rectangle of width 25, thickness 12. Actually, remember now, the cross section is the most important part of this subject. Actually, important of entire structural engineering for that matter. Okay, now, one powerful note you have to write. See, load in kilonewton, some millimeter, some millimeter, some meter. That it is their choice. They can give whatever way you want. When you solve in this chapter, simple stress and strain, see, it changes later. When you go to some other chapter, we may change the unit. But in this chapter, what we will do is, you make a note here. We will solve in newtons and millimeter. Class means I am telling here, you should write. He told that we will solve the question in newtons and millimeter. So many people has problem for units. I have got my own way of rectifying it. I will tell it clearly next time. So today you just make a note. In the class told, solution will be newtons and millimeter. Okay, leave it now. Start. Data. I told systematic solution. First I need axial force P, 48 kilonewton. I want Newton, 10 to the power 3 Newton, tensile. Okay. Then original length L, 2.8 meter or 2800 mm. Some will tell, why not 10 to the power 3? No. Meter to millimeter, I multiply by 1000 and write. Kilo to Newton, I use 10 to the power 3. My habit. Then the most critical part, cross-sectional area. See, this area, more information next time is here 25 by 12. It will become 300 mm square. It is given in the question. See, this is E. E is separate, epsilon is separate. E is modulus of elasticity of material 200 Kn per mm square, convert to Newton, 200 10 to the power 3 Newton per mm square. Now, start one by one. First they want intensity of stress, sigma equal to P by A. Substitute P, substitute A. Next class I will explain. Actually you can make out now. Force in Newton, area in mm square, stress will come in Newton per mm square, but still this all I am explaining. Systematic way I will explain. So answer is 160 Newton per mm square tensile. Okay, next. Second, what they want. See, examination, this is the way to solve. Not randomly write something. This all, each chapter I will tell you how to systematically solve. Change in length, see, delta. Formula, PL by AE. P is given here, 48 10 to the power 3. Length is 2800, area is 300, E is 200 to the power 3. Delta will come in millimeter. Why? Because it is a linear quantity. Tomorrow I will tell you, see the units here, not tomorrow, next class. See the units here, I will tell it why comes in millimeter like that. Now, right now, okay. See, today's class, lot of things you have to believe me. 3, they want strain. See, not Young's modulus, strain, epsilon. Basic formula, change in length by initial length. Divide. In my class, strain, I always want 10 to the in terms of 10 to the power minus 3. So divide, you get 0.8, 10 to the power minus 3, tensile. Okay, now, lastly they want strain energy stored U. I told two formula. Basic formula is half P delta, half into P. P is here, delta is here. Substitute. Energy will come in Newton millimeter. Remember, this also I will tell you. Unit tomorrow, next class. You habit of telling tomorrow. Okay. Or what if you replace this also I told just now. Or you can use U equal to P square L by 2A. Substitute. You get the answer. Question over. Now make a note just to understand. See, you write a note. For stress, we found stress equal to P by A. That's the only way to find it. Now, delta we found by PL by A. Note. See, we also have, this is note, you write here. Extra portion I am doing here, extra to understand. We have delta, if you find in terms of what? If you find in terms of force, based on force, PL by A. But so many times, you will not be knowing the force. Important is stress is known. Then the formula is stress into L divided by E. This side E, not epsilon, E. Substitute here, stress, how much you got? 160 into L is 2800 divided by E is 200 10 to the power 3. I am not calculating, it will come, but anyway, I will calculate so that if any calculation mistake is there, I can make out now. 160 10 to the power 160 into 2800 divided by 200 10 to the power 3 is 2.24 millimeter. First of all, in my class, I never check this way because I got 100% confidence. Answer will come. Increase. Okay, that is understood. Increase over. Or next year, see delta over. Now next we have strain equal to strain epsilon equal to we found by delta by L. There is one more formula. See, first one thing, first find stress. See, always forgot here. First find stress. First find stress. Answer is we get sigma equal to same P by A. Sigma equal to P by A equal to, I will write direct answer because already it's known here, 160 Newton per mm square. This is already known for you. 160 Newton per mm square. Then find delta based on stress. Or now find strain also based on stress. See, or strain equal to, I told already, it is stress divided by Young's modulus. Substitute here, 160 divided by 200 10 to the power 3. Again, waste of time calculating, but I will calculate just for checking purpose. Therefore, your strain epsilon will come 160 divided by 200 10 to the power 3 is 0.8 10 to the power minus 3. 0.8 10 to the power minus 3 tensile. Okay. Tensile. Now important. Now, based on strain, you can find delta. Or now, if you want delta equal to, that is using strain. This you require for the last part of this chapter. See, I told you, using strain. In the first part, you find delta by PL by A. Little later, when you go to temperature stress all, you find by F sigma L by E. But when you go to lateral strain, linear strain problem, you always find by this formula, delta equal to strain epsilon into L. That way, if you calculate, answer will come. Strain is 0.8 10 to the power minus 3 into length is 2800. Therefore, your delta will come 0.8 10 to the power minus 3 into 2800. Oh, something went wrong there. 2800. 2.24 millimeter. 2.24 millimeter. Since member is in tension, okay, it is increase over. Okay, now last one. Sometimes they may not give area for you. They may not give length for you. Simple question, 5 marks. They will stress, they will give. Young's modulus, they will give. They will ask strain energy stored. It is like, then you cannot find this strain energy stored this way. This is a total energy stored. I can make a note here. This is total. This is strain energy stored total. Then you cannot find total. As usual, I told you, I give plenty of examples. Like, suppose you go to a shop. Suppose you want to have coffee. You decided to have 4 coffee. 4 people go. 4 coffee or juice. Okay, why coffee always? Juice is better. 4 juice you want. Imagine each juice costs 30 rupees. You tell the shopkeeper, give me 4 juice. He will tell how much? 120 rupees. Total. Suppose you just go and ask him, what is the cost of juice? He will not look at you and tell, if all 4 of you are taking juice 120 rupees, suppose you make 3 by 4, it is only 90 rupees. He won't tell that way. Or if you make by 2 by 2, it is only 60 rupees. Or if only one person takes juice, others keep quiet, it is only and by 2 you make, he will not tell that way. What he will tell? If you tell him the total number of juice you require, he will tell 120 rupees. But if you don't tell that way, simply tell, how much juice? He will tell, sir, 30 rupees per juice. That is, for unit, you will tell for unit, 1 unit. So, or remember, I had to bend and write here, but I'll check the camera first. Same problem. Do not want it. Yes, I can manage. I can manage that one. Or just make a note. Or make a note. Last one. See, epsilon. Sorry, not epsilon. Lastly, U. We found U equal to that formula. It is a total. Now do one thing. Or see, U is also equal to sigma square by 2E per unit volume. Per unit volume. Then I write here. I have to bend and write. Okay, I write here now. Then I write here. Then your U equal to sigma square. Where is sigma? 160. 160 square divided by T2 divided by 200 10 to the power 3. 160 square divided by 2 divided by 200 10 to the power 3 is 0.064 Newton millimeter per millimeter cube is the answer. Now, suppose in the shop, you tell how much is the juice. You don't tell how many juice you are buying. What you will tell? Sir, 30 rupees per juice. Then you tell him, we want 4 juice. He will tell, sir, please give 120 rupees. Same way. Once you get this 0.064 Newton millimeter per millimeter cube, now you can do one thing. You can find the volume, correct? See, for unit volume, it is this much. Now, what is the volume of member? You should write yourself only. The volume of member is, area is 25 into 12 into length is 2800. It is coming 84,000 millimeter cube. For 1 millimeter cube, this much energy stored. Therefore, you can tell total or U total equal to 0.064 into the volume. Volume is how much I told? 84,000 mm cube. Answer has to come whatever you got here into 84 exponential 4. What is happened? Something happened here. 0.064 into 84 10 to the power 4. 53760. 53760 Newton millimeter. Now no per. See, once you tell him, I want 4 juice, he will not tell per. He will tell, give 120 rupees. That way. See, same answer what you got here. Complete this question. Now I will do one thing now. For you, I will give homework. Work out today only. Only change is, member is not rectangular, it is circular. That much you should be knowing. If rectangular section is there, area equal to width into thickness. If circular section is there, area equal to pi into diameter square divided by 4. That much you should know. Therefore, I will give a question. I will dictate the question with answer. See, I will dictate the question with answer and I won't write anything on the board. I will keep on telling the answer for you. You write, a steel rod of length, I'll write somewhere here, steel rod of length 0.8 meter. See, I am taking small length, there is a reason for it. You don't worry it. Is of diameter 32 millimeter. It is subjected to not tension, axial compression of 804 into 125. 100 kilonewton. 100 kilonewton. Okay. Take E equal to same as this question. How much? 2, you take 2 10 to the power 5 Newton per mm square. No kilonewton. Newton per mm square. Question is find same this 4. So I will give you answer for homework. For homework, I will write here. Your intensity of stress will come. I will directly give the answer. Pi by 4 of 32 square is the area. Reciprocal. Same way. Solve by different ways. How I solved here, solve same way. Reciprocal into force is how much? 100 kilonewton. 100 10 to the power 3. It is 124.33340, third decimal, Newton per mm square. Compression, you should write it. And change in length is, this is the answer for homework actually. Change in length is the stress. Length how much? What is the length? I give length there, 0.8 meter into 800 divided by E value I told, 2 10 to the power 5 is 0.4974 millimeter. Decrease. And then they want what? They want strain epsilon equal to 0.6217 10 to the power minus 3 compressive. And energy stored U total is 125 P square, half into P. Where is P? P is there, 100. 1 paisa, 2 paisa, this side, that side, no problem. Rounding operator will be there. Half into P into delta. Delta is 0.4974. You solve the same way. 0.4974. 24870. 24870 Newton millimeter. Solve this question. You should tell yes, at least I know how to solve this basic question. Okay, now I am going to wind up this class. Further continuation, I told depends. You already told. I am not repeating once again. What is the condition on? You should not tell he is imposing something. No. When I am so much busy and I want to do a service-oriented class to help so many, in return, if you cannot do that much, I will be helpless. I will silently keep quiet. Now, just for a lighter side, I will tell a small story for you. As I told, a small story I will tell. This is not story class actually, but why I am going to tell this story, you can make out if you go through the story and what all I told in the beginning, if you compare, you can make out. That is left to you. See, olden days, there was a king. Then the king always will have a minister. He is immediately next to the king. The king told the minister, my subjects or citizens here are so fond of me that they are very happy with me. So whatever I tell, they will do. Even they are willing to give their life for me also. He told that way. The minister knows the reality, how the people actually are. He simply laughed inside, but told the king, okay, king, okay, we'll have a test for it. King told, okay, go ahead for that one. So the minister made an announcement. It is a king's order that is, king is asking everybody, tomorrow morning, all should come to the capital near palace where there is a big tank-like structure is made. In the top, there is a small opening. Everybody should put 1 liter of milk there. Actually, some of you may be already knowing this king and minister, who they are. Actually, it's a very popular story in India. Names or I will not tell. So, the minister made the announcement for public announcement. So all should go. And one more thing, when you bring the milk, you should cover it completely. No one should see it. One by one should go there, put it milk inside and come out. That's all. That way announcement made. So next day morning, almost everybody in the capital area, maybe in lakhs, they came, and what was asked for them, they did that one. Then the minister took the king up, and everybody left. Come, let's see the result now. He told the king, open that door or that cover and see inside. The king opened the cover, and when he looked down, to his surprise or shock, there was not a drop of milk in that one. It was full of water. The king can't understand what is happening. Lakhs of people came here and still not a single drop of milk. How it is possible? The minister told him, see, king, you think that the people are like that, but what you think really is not correct. Everybody, they have selfishness. So everybody thought, when so many lakhs of liters of milk is poured inside, suppose why should I waste milk? Suppose I take, anyway they told what? You carry the milk without showing to anybody. If I put instead of milk water, nobody can make out. Why? So much huge milk quantity, 1 liter water, nobody can make out. Then minister told him, see, same thought came to everybody. So each and everybody thought same way. Why should I waste the milk? So therefore, they put only water there. Actually, the story ends here. As per our Indian history, the story ends here. But I would like to continue for 3 more lines. Then the king told the minister, to be frank with you, what I decided is, what milk they are going to give. Small, 1 liter milk, small contribution. I thought I will prepare some, he will not prepare, he will ask people in the palace to prepare some sweet, maybe rasagulla like that, which can be made of sweet. And also, to make the people happy, I decided to arrange a grand food festival. If everybody will be asked to come to the palace, and food will be given, grand food will be given for everybody. That all king told, I will take care. Their contribution, just a liter of milk. Then he told, no, now I decided not to go ahead that one. Why? They don't deserve it. If they are showing selfishness to put milk, just instead of putting milk, they are putting water, thinking that what, if I can save the milk, when I can save the milk, it is useful for me. He never thought other way. Therefore, it decided, no, it is cancelled. Why I told the story? If you think, you can make out. Now, one last thing. People can tell, why he is insisting so much actually, or imposing something on us. Not imposing. In my busy schedule, I am so busy, you don't know how much. Sometimes I take marathon classes for 4-5 hours at this age. And then when I get a free time, I want to relax or enjoy. Still I thought, let a course be conducted so that it is useful for many, many people. So then, if I don't get good response, and if people simply use it and keep quiet, then I will decide they don't deserve it. See, they don't deserve it. Therefore, why should I continue? I am that type only. Not that I want people to praise me or accept like that. But they should show the response. What all I told in the beginning, go through again, and you decide whether class is to be continued or not. Now, I will conclude the class now with the story. Just lighter side only I told story now. I will conclude the class. Next class number 2, I am going to upload in another 1 or 2 days. I won't wait for anything for class number 2. Class number 2 I will upload. Then I will decide, shall I continue the course or not? If I continue the course, okay, well and good. Otherwise, class number 2 will be there. Then I think at least you can tell that class number 1 and 2, is really useful for us. I learned, you can, I means you only. No, I learned a lot of things. If that you feel, okay, at least my effort is rewarded here. Okay, that's all. Further, we will meet in class number 2. Then we will see further later for class number 3 onwards. Okay, thank you for going to the class. Come up in education, learn and gain lot of knowledge.